So after we just talked about what oxidation and reduction means, now we're on to the next section, which is about glycolysis. And so glycolysis is the first step of cellular respiration, and so we're starting off with glucose. Glucose is what we start cellular respiration with. It's the first product from photosynthesis, and so it goes straight into cellular respiration. And the first step is glycolysis. So glycolysis literally means splitting sugar. Glyco means sugar, like glycogen, and glycosidic linkages means sugar, and olysis means breaking down of. So hydrolysis is when we broke water to split molecules, right? So this is when we're breaking things down. So we're starting with glucose, and we're going to end with 2 molecules of pyruvate. There's a lot of different steps, but you don't need to know all of them. But you do need to know that it happens in the cytoplasm. So we're still inside the cytoplasm of all cells. So in a eukaryotic cell, it's going to happen in the cytoplasm. In a prokaryotic cell, it's going to happen in the cytoplasm. And there's 2 major phases. So it's not just like we split glucose in half and get energy. We have to put in some energy to get any energy out. So there's the energy investment phase where we actually put in ATP. But then there's the energy payoff phase where we get more energy out than we put in. So it's actually, we're coming out with more energy at the end. And glycolysis is anaerobic, which means that it happens whether or not oxygen is present. So all living things perform glycolysis if they use glucose as a source of fuel. So we start off with glucose. We're going to put in 2 ATP because we need to put in some energy to get this to happen. And then when we come out, we're going to get 4 ATP and 2 NADH. So there's a lot of steps. But basically, the main thing that you need to know is that we put in glucose. Then we put in 2 ATP. And this 2 ATP is kind of like, it's just like kickstarting the reaction. Like we need to put something in to get something back. Like if you were going to start a business, you would need to pay the costs up front, but hopefully in the end, you're going to make more money than you spent. So we spend 2 ATP, putting in 2 molecules of ATP to get energy. But then out of the equation, we get 4 ATP. So overall, we gained 2 ATP. Glycolysis gives us 2 more ATP than we started with. So we're winning. We're coming out on top. More importantly than those 2 ATP are the other things that we get. We get 2 pyruvate. Pyruvate is going to enter the citric acid cycle in the next round of steps. And we're going to get even more ATP and even more high energy molecules like our NADH. NADH is going to carry electrons to the electron transport chain, where we're going to get ATP from oxidative phosphorylation, which gives us so much more ATP than substrate level phosphorylation. So right here, these ATPs that are made, these 4 that are made via substrate level phosphorylation. So that's why we're not getting very much ATP out of it, because substrate level phosphorylation doesn't give us as much as oxidative phosphorylation, which we do on the electron transport chain. So we get 2 pyruvate. As a consequence of that, we also get 2 waters. Because remember, glucose is being oxidized, and so oxygen is being reduced and picking up the electrons and becoming water. Then we get 2 ATP made, but we have to put in 2 ATP. We get 4 ATP formed and 2 ATP used. So overall, we have 2 ATP coming out, and we put in 2 NADH, and these 2 NADHs accepted electrons, and now they're 2 NADH. So that's the overall net. So we start off with glucose, and basically what happens is we put in an ATP. This ATP attaches to glucose, and that becomes glucose 6-phosphate, which just means glucose with a phosphate on it. This is very unstable, so it quickly becomes fructose 6-phosphate. We put in 1 more ATP, and now we're fructose 1,6-bisphosphate, which means a fructose molecule, which is a monomer of a sugar, with 2 phosphates on it. Okay? Then this molecule is so unstable that it instantly snaps into 2 different molecules. So we have 6 carbons, 6 carbons, 6 carbons, 6 carbons. Now we have 2 molecules that each have 3 carbons. So we still have 6 carbons. We haven't lost any carbons yet. It's really important that you account for your carbons. Okay? So we started off with 6 in 1 molecule. Now we have 3 in 2 molecules, so we still have 6 carbons. Very important. So this is the energy investment phase. We haven't gotten anything out of it yet, right? We put in 2 ATP. So overall, right now, we're down 2 ATP. But then comes the energy payoff phase. And then, in the very first step, we get out 2 NADH. That's big. We want this NADH. Then, we get out 2 ATP via substrate level phosphorylation. And then finally, we get 2 waters right here, and then 2 more ATP. So overall, we have gained, where did it go? Back to that first slide with the picture. We've gained 2 pyruvate and 2 waters, 2 ATP, 2 NADH, and 2 H pluses. Through the energy investment phase, where we put in 2 ATP, and then in the energy payoff phase, we got 4 ATP, 2 NADH, which are going to turn in much higher energy later, and 2 pyruvate. And that's glycolysis.